It's the Bundeswehr's most modern aircraft, developed to dominate the skies. Top speed, almost 2,900 kilometers per hour, twice the speed of sound.
I've flown a lot of airplanes, and it's by far the most powerful one I've ever flown. I mean, it's just pure performance. The engines are amazing.
This fighter jet was developed jointly by 4 European countries: Germany, Great Britain, Italy, and Spain. In Germany, the Eurofighter is assembled in Manching, Bavaria. This is also where all German Air Force aircraft have their routine maintenance work done.
It's like in a car repair shop. After 600 flying hours, every German Eurofighter comes here for maintenance.
Because in the air, every technical failure can mean the difference between life and death. This fighter jet is driven by 2 jet engines. Even without an afterburner, they're extremely powerful.
The Eurofighter generates a total of 100,000 horsepower, as much as 150 Ferraris.
With an afterburner, the fighter jet's engines can actually deliver 150,000 horsepower. That makes the Eurofighter the only fighter jet capable of flying supersonic 9G maneuvers. Manching, 75 kilometers north of Munich. Fighter jets and other military aircraft take off and land here every day. All German Bundeswehr Eurofighters are built and maintained here. For the construction of the Eurofighter in the European program, the fighter jet's center fuselage section is outfitted here. The Eurofighter program is a partnership between Great Britain, Spain, Italy, and Germany. Different components are manufactured in each country. The front section comes from Great Britain. The rear fuselage is made in Italy and Great Britain. One wing comes from Italy, the other from Spain. Germany manufactures the center fuselage section.
The historical background is that we already had a partnership program before the Eurofighter, a European one, the Tornado. And in the case of the Tornado, Germany had already built the center fuselage section. The competence for the systems and also for the work in the center fuselage was built up at that time. This was then transferred to the Eurofighter.
The Eurofighter is an all-weather twin-engine multirole combat aircraft. It's powered by 2 engines with a maximum output of about 150,000 horsepower in afterburner operation. This enables the fighter jet to reach a maximum speed of Mach 2.35, or 2,900 kilometers per hour. It's nearly 16 meters long, has a wingspan of 11 meters, and weighs 11,000 kilograms when empty. It can hold more than 6,200 liters of jet fuel. Its combat range, up to 1,300 kilometers when fitted with supplementary fuel tanks. It can be flown at an altitude of up to just under 20,000 meters. The small front wings are particularly striking. Without the added stability provided by this electronic aid, the jet would not be airworthy. Price, depending on armament, about 130 million euros. Manching, the hall for the final assembly and center fuselage section outfitting. Up to 10 fighter jets are built here per year. The necessary assemblies are processed in these docks.
We use what we call the dock principle here. This means that the center fuselage section remains in this dock until it's finished.
The center fuselage section will remain in this dock for the next 45 workdays. 2,500 work steps are to be completed. Because the Eurofighter comprises various components assembled at different locations, there is no wiring harness like in a car. Everything here is made by hand. The cables are supplied in pre-assembled bundles. These must then be connected in the center fuselage section. Every cable in each bundle is labeled individually.
We know which pins belong to which cables and which connector they correspond to.
The cable bundles are rolled out, checked, and only connected during installation. Because the shorter the cables, the less they weigh. Connectors then combine the cable bundles to form a wiring harness.
That sounds complicated, and it really can be. Take this plug, for example. It has 128 wires attached to it.
Some of them have to be specially shielded to prevent other aircraft or radar systems from intercepting sensitive data and to protect the jet from outside interference. Connectors are fitted to a cable only after it has been installed in the fuselage. Each connector is installed individually by hand.
You have to do this by hand for every cable, every connector, every pin.
Only calibrated crimping tools may be used.
Perfect. Now it's fully crimped.
Not only are the cables labeled, now the new plug-in connectors are also documented and attributed to individual technicians. As a result, it's always possible to trace who installed which plug-in connector in which fighter jet and when.
When I finish assembling the connector, I have to enter my ID number to tell the system that the connector is complete and that I did it.
The crimping tool is also recorded in the system. If a subsequent tool inspection determines that a given crimping tool is out of tolerance, all connectors assembled with that out-of-tolerance crimping tool must be replaced. No exceptions. In all, some 30,000 plug connections are crimped and documented, and some 15,000 cables are routed in this way during the construction of a Eurofighter in the center fuselage section alone. With over 680 orders from 9 customers, the Eurofighter is currently the largest European military aircraft program. During the Cold War, military experts anticipated Russian air attacks. Accordingly, in 1983, then German Chancellor Helmut Kohl requested support for a pure fighter aircraft. One of the biggest challenges in this advanced development was the so-called swing roll capability that the fighter jet was required to have. The ability to switch between attacking targets in the air and on the ground in a matter of seconds at any time during a mission. On August 2, 1985, Germany, Great Britain, and Italy signed an agreement on the implementation of the Eurofighter program. Spain joined 1 month later. The first test flight of the Eurofighter prototype was conducted by pilot Peter Vega on March 27, 1994. Nine years and 7 additional prototypes later, the time had come in 2003. The first production units finally left the factory in Manching, Bavaria, Wharton, England, Turin, Italy, and Getafe, Spain. 148 aircraft were produced in the first version, the so-called Tranche 1. In April 2004, the German Air Force officially put the first Eurofighters into service, with Fighter Wing 73 in Lage, Germany. Delivery of Tranche 2 then began in October 2008, already including nearly 400 modifications compared to the original delivery. Over the course of the following years, the electronics inside the fighter jet were particularly subject to several major upgrades, while the outward appearance of the aircraft remained virtually unchanged. Another special feature of the Eurofighter is the transformation of its armament. While the Eurofighter was originally conceived as a fighter aircraft, its range of use has now been extended to include combat against ground targets, and with the appropriate armament, even for use as a bomber. In the future, the Eurofighter will also be able to engage remote targets such as radar stations, bunkers, and bridges. In addition to the 4 original partner nations, 5 other countries have now also placed orders for Eurofighters. Manching Airbus. The assembly of fighter jets differs considerably from that of civilian aircraft. Tight installation spaces often make the work very difficult, and every work step must be recorded, checked, and confirmed. All required parts are provided as needed at the respective dock and are always available in excess quantities.
The big advantage here is that the employee proceeds with his work order. He takes this pipe, he takes the other components he needs and installs them. If a part fails during installation, he can simply take a new one and continue. There's no need to interrupt his work.
If a part is missing, employees can request it from the warehouse.
I look to see where the material carrier is located. It shows me that it's in the park position, in storage. That means I can request it. Now it's been requested and we just have to wait for it to arrive.
A high bay warehouse is located directly behind the docks. All the parts required for installation in the center fuselage section are stored there. Small assemblies are arranged together in a large metal cabinet, and the entire cabinet is then rapidly transported to the dock. In all, some 3,000 different parts are stored here, waiting to be installed. An urgently needed component has arrived in the incoming goods department of the assembly hall. It's a hydraulic drive. Before it can be installed in the aircraft, steps must first be taken to ensure that it meets all safety requirements and that it has no quality defects or possible transport damage.
The screws here must be sealed, and the wire must be wound the right way. That ensures that it can only turn in one direction. The part will now be passed on to our warehouse staff, and they will store it or send it straight to the production area, because it may be an urgent part that needs to be installed right away.
All larger parts are temporarily stored in the so-called buffer warehouse. The Eurofighter was originally built for aerial combat. In recent years, however, it has been used not only as a fighter jet, but also as a bomber. The bombs are located under the wings. A laser seeker and GPS control system are mounted in the front. They guide the bomb to its target. The Eurofighter has enough thrust to carry 4 bombs at the same time. The pilot does not have to be above the target when the bombs drop. They're programmed with GPS data and find their way to the target on their own. The mission plan calls for target practice. First, these containers are to be hit. They've been marked as ground targets and will now be engaged. The jets are carrying blue practice bombs without explosives. These bombs are intended for use from medium to high altitudes. However, the target must be precisely measured with coordinates beforehand. As a result, no visual contact with the target is required, so they can be used in any weather.
T1 is turning in hot, start of run. Roger.
Will both practice bombs find their target?
Stand by release. 3, 2, 1, mark.
12 kilometers from the target, the Eurofighter sends the bombs on their way. From here on out, everything happens automatically. The first one hits the target perfectly, and the second one misses the center by just 2 meters. 2 hits from a distance of 12 kilometers.
When we're supporting ground troops, it's possible that while already in the air, we may be called in to help when ground troops are attacked, to fight the enemy. And then we don't even know beforehand which direction we have to fly and what exactly to expect on the ground.
The pilots then have to select their own targets. To do this, they have to fly in visual contact. The cloudier the conditions, the lower they have to go to identify and measure their targets. The pilot has a special visor in his helmet for this purpose. Looking through it, he can mark the target with crosshairs. The jet then calculates the coordinates for the target and transmits them directly to the bomb. This allows the pilot to mark and attack targets on site. All practice bombs find their target without any trouble. The test is now complete. The jet returns to base. The next morning, this time the Eurofighters take off with live bombs under their wings. The weather is clear enough for an attack using laser technology, an alternative when the GPS signal is disrupted. The pilot aims at the target in flight using a laser beam. The laser can be seen here on the left. This means that the pilot can easily detect even small vehicles such as cars and define them as targets from an altitude of up to 10 kilometers. In fractions of a second, the laser then measures the distance to the target and records it. The bomb is then programmed for this target. No further correction is necessary after dropping. MTU Euro engines, Munich. Aircraft engines have been built here for more than 100 years. The 2 EJ200 engines for the Eurofighter come from here.
To make a rough comparison, an EJ200 delivers 50,000 horsepower. In other words, the Eurofighter produces a total of 100,000 horsepower, as much as 150 Ferraris, for an order of magnitude.
The engine achieves its maximum output of 150,000 horsepower in afterburner mode. Due to extremely high fuel consumption, however, this can only be used for short periods of time.
In dry thrust mode, without the afterburner, an EJ200 consumes about 75 kilograms of fuel per minute, whereas in afterburner mode, it consumes 250 kilograms per minute.
In principle, an engine works in 4 stages. It draws in air, compresses it, burns fuel with the compressed air, and then discharges the combustion products from the back of the engine. It draws in air at a rate of about 75 liters per second and then reduces its volume by up to 26 times. It's like squeezing 75 liters of water into a 3-liter bottle. Afterburner operation is only possible for a short time, for extreme maneuvers or acceleration. In this case, the burnt air is mixed again with jet fuel and reignited. The nozzle is also closed, which raises the airflow exit speed even higher, thereby increasing the thrust. The Eurofighter does not need afterburner operation to reach supersonic speed, also known as Mach 1. At an altitude of 11 kilometers, Mach 1 is reached at around 1,062 kilometers per hour.
You see the display exceeding Mach 1, and you might see a little wobble in the altimeter when the pressure wave hits the plane and the instruments. But you don't feel it in the plane. You don't hear it. You don't see it. It's just the display indicating that you're traveling faster than sound.
Back in Manching, this is where the latest German Eurofighters are built. Today, there's a wedding. The cockpit and center section of a Eurofighter are being joined together. To do this, all smooth surfaces that will later overlap have to be coated with liquid metal. After all, the jet has to be able to withstand even the toughest conditions in combat.
This is a liquid shim. In other words, something like liquid metal that you use to even out surfaces. So the front part fits together flush with the fuselage and has no air coming in.
After assembly, the two parts should form a single stable unit. To achieve this, the cockpit is slowly pushed towards the center fuselage section on a trolley. Millimeter by millimeter. All cables must be fed through the openings. Under no circumstances should anyone damage a cable.
We can see the distance from here. It's still too large. Now the colleagues on top have told us that we need to lower it a bit. So I have to move it down about 1 centimeter because we still have to move it backwards to its final position. But we can only do that by moving it down first.
The bolts will not fit unless the two components are perfectly aligned. It's no longer a matter of millimeters. It's less than that.
It's a very tight fit. There's maybe 1/10 of a stud left to go. Yours go in? I'd say mine goes in too.
The process now continues in tiny 1/10 of a millimeter increments. Ultimately, all the holes must line up.
Wait a minute. Yeah, perfect. That's perfect.
When everything lines up perfectly, all pins can easily be inserted by hand. Central Material Warehouse, Military Air Spares Center. Up to 100 truckloads of small parts for the construction and maintenance of the jets arrive here every day. All consignments are recorded and documented. Every article, down to the last screw, is given a number and an identity. This means that from this point on, the current location of each part in the factory can be seamlessly traced.
I take a box for each item and link it in the system to the material with the consignment number. As soon as it's linked, I can put it on the conveyor system and send it to the storage location where the incoming goods receipt clerks retrieve it according to priority.
This is because the parts cannot be installed immediately. Every consignment of goods delivered must first undergo a so-called incoming goods inspection. This involves not only checking the documents, the component is also photographed. Only then are the goods transported along the 450-meter-long rail system to the warehouse, where robots store them in high bay racks.
We have 4 storage and retrieval systems. That means 4 aisles, each with a row of shelves on the left and right. Each rack is 12 meters high and 100 meters long, almost as big as a soccer pitch. This means that we can store around 300,000 different parts here.
Large parts, such as wings or engines, on the other hand, are stored separately. There's a separate hull for the tires. Here, the temperature and humidity are constantly monitored and documented. The tires are rotated every 3 months to prevent deformation.
The employee comes and rotates the tire by a quarter turn and then documents it. With our data sheet, we can keep track at all times which tire has been stored where and for how long, and also whether it's been rotated.
Rare and high-quality electronic parts are packed in wooden crates and stored in a separate high bay warehouse, which can be relocated for space reasons. When a new part is scanned for storage, the computer immediately calculates where it can best be stored and automatically opens that aisle. This means that only the aisle currently in use is open. MRO hangar, maintenance, repair, and overhaul. There are 16 different Eurofighter workstations here. Technicians distinguish between 3 different types of work on a jet: maintenance work, repairs, and complete overhauls.
It's like a car repair shop. After 600 flying hours, every German Eurofighter comes here for a full maintenance checkup.
As a rule, the pilots fly their fighter jets directly to Manching and land on the adjacent runway. The jets land without any armaments. The respective flight squadrons remove them before the maintenance work is due. The first step is to drain the jet. All fluids are drained, including the fuel. Only then is it moved into the MRO hangar. To transport it to its assembly area, the Eurofighter is lifted with a crane. The empty fighter jet weighs almost 11 tons.
The 11 tons are not evenly distributed, however, and we want the aircraft to be balanced at all times. That's why the cords are attached to the aircraft. When the load, in other words the aircraft itself, swings up, we can counteract it and re-establish a normal lifting position.
Then, the 2-hour tour through the hall begins. Not from 0 to 100 kilometers per hour in 2.4 seconds as usual, but slowly and carefully. After all, a fighter jet costs more than 130 million euros. And there are around 16 Eurofighters parked close together in this hangar. For safety reasons, even the small explosive charges for the ejection seats have all been removed.
If a fire were to break out here in the hangar, there would be the obvious risk that not just one aircraft might catch fire, but several at the same time. So we remove everything to minimize the risk of damage.
The fighter jet lands gently on its assembly area. It will spend the next few months here undergoing routine maintenance. In action, a Eurofighter lands at around 260 to 280 kilometers per hour. Its landing is much slower here. However, before the employees can start their work, all openings must first be covered with these red caps. There's a simple reason for this.
We use these red caps to prevent injuries, but above all to prevent foreign material from falling into any openings. A small piece might be dropped during maintenance. Stuck in the wrong place, it could have fatal consequences in flight.
This Eurofighter is undergoing the so-called backlash test. This involves testing the hydraulic lines and bearings of the Eurofighter's small wings for possible wear. The mini wings are controlled by the Eurofighter's flight control system and keep the jet airborne. Without them, the Eurofighter would inevitably crash. This is because the Eurofighter is an unstable aircraft. It always wants to break away, which is why it must constantly readjust the small front wings.
The advantage of this design is the maneuverability. If I'm in a stable aircraft and I want to maneuver in a dogfight, the jet will be very slow to change its flight attitude. That makes it slow to maneuver. Say I switch off the Eurofighter's control system, it would immediately leave the stable flight attitude. This agility is something that I consciously want to enforce during development. But you have to accept that under most operating conditions, when you just want to fly straight ahead, for example, you have to exert a lot of effort just to keep the jet in that flight attitude.
Then the test begins. Highly sensitive motion sensors are used to wiggle the front wing to see whether the bearings on which it's mounted are worn or have play. This motion cannot be seen with the human eye.
If there's any bearing play, it will appear on this force displacement curve. Now, if there were any spikes, that could indicate bearing play. This curve looks very good, though. It couldn't be better.
One station further on, the landing gear is being tested. The wheels are also driven by the same hydraulic system that moves the wings and rudders of the jet. All this is controlled by the flight computer, the brain of the jet. In the Eurofighter, this system has 4 redundancies. That means it's available 4 times. Only a failure of all 4 computers at the same time would cause the aircraft to crash. Now, the engines are being separated from the jet. To do so, the engines, which weigh about 1,000 kilograms each, are loaded onto a trailer and taken to another hall. There, each engine is inspected, dismantled, and repaired. In this way, the engines can be serviced in parallel with the jet.
This is an engine from base maintenance. The engine was dismantled there. It's like taking your car to the repair shop. We do a full inspection and show the customer, in this case the Bundeswehr, what we found. Then we repair everything and mount the engine back onto the aircraft.
In peacetime, the maintenance intervals are significantly longer. In wartime, the engine can perform better in the so-called war setting. This increases the maintenance effort, however, and shortens the service life.
We always have the most wear parts on our thrusters. Here we have the 12 external flaps. And this is where the thrust nozzle constantly opens and closes. And this is where our parts are most subject to wear.
During every full routine maintenance of a Eurofighter in Manching, the engines are also inspected. Because they comprise 1,800 individual parts, the inspection takes several days. At the end of the inspection, the Bundeswehr receives a detailed repair list for each engine. The Eurofighter is only flown by the best of the best. Stefan Leutner is one of them. He's been flying for 20 years, 10 of them as a Eurofighter test pilot. Every change to the aircraft, every upgrade is tested by him in the air. Even after 2,800 hours of flying, his pre-flight routine is always the same. He checks the plane again, not only because he hopes to find any faults, but also to prepare himself mentally for the mission.
It also helps you get into the mindset. Now the flying starts. I'll have another look around. I'm starting to focus.
Even as a child, he was fascinated by aviation. After a career in the German Armed Forces, he later joined Airbus and became a test pilot. But flying a Eurofighter is always something special.
I've flown a lot of airplanes, and this is by far the most powerful one I've ever flown. It's pure performance. The engines are amazing. The thruster-weight ratio, the performance in turns, the pitch rates I get. In other words, how quickly I can maneuver the plane. It's impressive. I've never flown an aircraft that could compare to that.
Normal flight in the Eurofighter is no great challenge for the pilot. The flight computer controls the aircraft. The jet is easy to fly using a joystick, just like in a computer game. The pilot is unaware that the aircraft is actually unstable and cannot fly at all without the computer.
Imagine you're balancing a pencil on your finger and someone blows on it. And if you don't react quickly, the pencil will fall off. It's the same with the Eurofighter. The pilot no longer has to perform this task, the flight computer does it for him. We call it the flight control system. Without it, I wouldn't be able to fly the plane.
The Eurofighter is a single-seater. A two-seater is only available for training purposes. In flight, the pilot controls the jet with both hands. His feet perform no function in the air.
I have one hand on the stick and the other on the throttle, the gas lever. The stick and the throttle have all the controls: weapon selection, sensor operation, radio, everything I need. I also sit in the ejector seat, which is secured. I have one of these between my legs, a black and yellow lever, and that's actually for when I have to leave the plane. Then I pull it here, and it all happens very quickly. The roof comes off, and the seat flies out, and then I'm hanging from a parachute, within a second or two.
Ejection is always the last resort, as is the use of weapons. Its onboard cannon is secured behind a flap. Luckily, most Eurofighters have never had to use it.
You actually want to avoid constantly dragging this open gun barrel around with you. That's why there's a cover over it. When the time comes, you just shoot it off with the first bullet.
And the onboard cannon is vital for the pilots, because a dogfight with missiles often ends up in a direct man-to-man duel.
It starts far away from each other, each pilot firing missiles using long-range radar. Those ones you can evade with maneuvers. Then you get closer into the range of infrared-guided missiles. That means you're already in visual range where you can see the enemy. And if none of that works, at some point you engage in close one-on-one combat with the onboard cannon.
Somewhere over the Atlantic, German Eurofighters with live missiles under their wings. These have a range of up to 80 kilometers. In modern air combat, pilots shoot at unseen enemies. All the pilot has to do is take aim at the target, either by aiming himself or automatically by computer. Once a missile has been fired, there is no turning back. The German Eurofighter carries a maximum of 6 missiles. These can steer themselves to the target with their wings. In other words, guided missiles. 3.5 meters long, they have a rocket engine in the back, a small radar unit in the front, and explosives in the middle.
The net explosive content in the warhead here is around 7 kilograms. That may not sound like much, but this is not a bomb. We're talking about a guided missile and not some kind of large device. There are a high number of fragments inside which are accelerated outwards by the warhead when it detonates and engage the target.
The next Eurofighter formation is loaded with ammunition, ready for a test in the skies over northern Scotland. Shortly after the Eurofighters are in the air, other aircraft take off. Remote-controlled drones. These simulate targets in the air. In air combat, the first to spot the enemy has a clear advantage. That's why the Eurofighter's radar detects enemy aircraft at a distance of 100 kilometers. As long as the pilot is flying towards the enemy, the system updates the data in the missile. Once the missile has been fired, it takes over the hunt for the target. At a certain distance from the target, the missile switches to its own radar and then tracks the enemy independently. This gives the Eurofighter pilot the opportunity to turn away, increasing the distance between himself and the enemy. It's like chess in the sky. Shoot too soon, your opponent can spot you. Shoot too late, and you could be a target yourself. If a Eurofighter pilot is attacked by a radar-guided missile from a great distance, he must trust the performance of his jet. The missile only has limited fuel, so he simply has to keep it behind him for as long as possible. Then, it will eventually fall out of the sky on its own. The most important thing is to recognize the danger early on.
I see a trail of smoke moving quickly in my direction. In that situation, I know that someone may have just fired a rocket at me.
To fend off the missile, the Eurofighter also emits electronic jamming signals and attempts to deceive the missile with maneuvers. How exactly does it do this? Well, that's a secret. MTU plant in Erding near Munich. The EJ200 engines for the Eurofighter are made here. Each one comprises up to 30,000 individual parts. About 100 employees work here. Some of them are civilians and some are members of the German armed forces. In addition to building the engines, damaged engines are also repaired here time and again.
The engine that we receive from the customer, in this case the German Air Force, is usually one that doesn't work as it should. We dismantle it into modules and the modules into individual components as needed. The individual parts are then repaired here or in Munich. After reassembly, the engine is sent to Munich for final testing. If the test run is successful, then the engine is sent back to the customer.
The engine is mounted in such a fixture for easy access from all sides.
I can rotate it around its axis. I can orient it vertically with the afterburner pointing upwards. I can lower the stand into the floor, and I can move the engine down for the compressors, the front part of the engine, so I can get to all flanges without having to climb a ladder or get down on my knees.
Before MTU's specialists begin the repair work, the exact damage pattern is determined. This information is then used to determine the personnel requirements, the expected costs, and the turnaround time of the engine repair. In the next step, the colleagues from the disassembly department dismantle the engine into modules, sometimes even into individual parts. A bore scope is used to inspect for internal damage.
We are scoping the first stage here. The entry and this area that can be seen here is to be checked for any findings. Notches, dents, fractures, breakouts, grooves, deposits.
This is because only actually damaged parts are later removed and replaced. Damage to the engines is mainly caused by birds, whether sparrow or eagle. When an animal is sucked into the turbine, considerable damage can occur. The greatest risk of bird strike is during takeoff and landing.
This is a damaged high-pressure turbine, which shows massive impact, in this case from a bird strike. The impact broke apart further upstream and sucked it through the entire engine, damaging these parts.
In the event of bird damage, technicians dismantle the entire module into its individual components and completely rebuild it. In addition, a DNA test is carried out on the remains to determine what type of animal caused the damage. All parts involved in such incidents are also subjected to crack testing. The components are sprayed with fluorescent paint. It then sets in for exactly 30 minutes. The paint is then rinsed off and rinsed again in an immersion bath. Until there is no paint left on the component. This is followed by yet another rinse. If undamaged, the part is now free of paint.
After the washing process, the component is dried in an oven for 30 minutes at a maximum of 70 degrees Celsius.
There would still be paint in every crack in the component, no matter how fine. To ensure that no fluorescent paint has adhered to the surface, the component is subjected to abrasive blasting. Only then can it be placed under the black light. Any damage to the material would now be indicated by the paint.
There are no cracks. Component is okay.
The part can be reinstalled in an engine. After 3 months, the engine is sent back in these containers. They're filled with nitrogen. This protects the engine from corrosion. Manching, engine test hall. Every engine that has been reinstalled on a Eurofighter must be tested here. To do this, the entire jet is placed on the chain. Wire cages are then mounted in front of the engine intake ducts.
They protect both the aeronautic equipment and the people working here. I could have something in my hand and walk past the intake duct, and it could suck it right out of my hand or even suck up something from the ground. That object would pass through the engine, and it would cause catastrophic damage to the engine and possibly even to the aircraft. And we also want to protect the people, because if I got close to the intake duct, I could possibly, well, I don't want to say any more, but it could happen.
Because the Eurofighter is not level when stationary, the front wheel must also be lowered. This serves to level the fighter jet. And its exhaust must not hit the tunnel wall. In afterburner mode, it would easily set fire to the protective wall.
The exhaust leads horizontally into the exhaust duct, because otherwise I'd have another huge welding torch cutting the cladding out from underneath the exhaust duct.
But the test cannot begin before the plant fire department arrives. 3 firefighters must be present and ready for an emergency while the engines are being tested. This is required for all engine tests. They take their seats in a soundproof room just a few meters from the jet. Then, all employees except the brakeman in the cockpit and the ground test operator must leave the hangar. The front wheel has already been lowered. The jet is now horizontal. Then, the engine starts and the hangar is closed. The test begins.
This is the final assembly run. The aircraft is put through its paces one last time to see whether there are any faults. And if the test goes well, we can grant flight clearance and hand the aircraft over to the customer.
Now both engines are being put through their paces. The engine already passed the afterburner test yesterday. Today, it's time for the endurance test. This also checks whether one engine can start the other. If one engine fails in flight, the pilot can use the other one to help restart it. Everything works. The test is complete.
It works perfectly. No anomalies in the cockpit. Everything works fine.
The successful engine test also marks the end of the operation for the plant fire department. Flight and Integration Test Center. This is currently one of the best flight simulators in Europe. It's not just close to reality, it actually mirrors it 100%. So new technical components that pass the operational test here can also be installed in the Eurofighter. The only thing the computer cannot simulate is the effective forces acting on the pilot in the real aircraft. The rest is an exact replica of the Eurofighter's cockpit environment.
I can actually feed the simulator with data and use it in a way that it behaves exactly like the aircraft. Of course, I don't feel any movement or the 9Gs, but I can simulate the behavior and I can evaluate it as a test pilot. so there are no big surprises later on.
Stefan Leutner spends many hours a week in the simulator. This is also part of the job of a test pilot. A job that many people spend their whole life only dreaming about. Thanks to its unstable design, the Eurofighter is highly maneuverable and extremely fast. Its thrust-to-weight ratio makes it a deadly threat to its enemies. Its engines deliver enough horsepower to fly at supersonic speeds even without an afterburner. The fighter jet is built in a partnership program between 4 countries. In Germany, the fighter jet is assembled in Manching, Bavaria. Here, the German Air Force also performs routine maintenance on the aircraft. The Eurofighter is armed with its onboard cannon as well as missiles and bombs, enabling it to engage even remote ground targets from a great distance. It's one of the most dangerous fighter jets in the world. Eurofighter, king of the fighter jets.